Hello friends, I welcome you all to this session on graph theory. Today I'll be telling you about dual graphs, that how to draw dual graphs. But before that, you should know what is region in a graph or what are regions in a plane graph. So if you look this closely, consider a plane graph. This is the one, and let's say I'm interested in finding out the regions. So what is region? Region is basically a section in which a plane graph is divided. So if you look closely, so this is one section, then this is another one, and then there is this outside region which is unbounded. So how many regions are there, or how many regions in which this plane graph is divided? So there are four regions. What are those? This is region number 1, this one central one is region number 2, and the another one, that is the outside one, that is region 3. So regions are basically those sections in which a plane graph is divided. Now once you know about region, or let me ask you, let's say that this is a graph. So if I ask you that how many regions are there in this graph, then we have to count. This is region 1, okay. This is region 2, region 3, region 4, region 5. Is it over? No, you should not forget about this region which is unbounded region. Region are also called as faces. Okay, so that's all about region. Once you know a region, then you will be in a position to draw the dual graph. One more thing, if I am having a graph which is not a plane graph, let's say this is the one, and I have been asked to find out the region, then what I have to do? What I have to do is I have to convert this graph into a plane graph. And if I am able to convert it, then only I'll be able to find the regions, otherwise not. So let us copy this particular graph, bring it here. Now what I have to do, I have to convert this into plane graph. So what I'll do is I will remove this edge from here, okay, because this is what the intersection point is, and I will draw it from outside. Now the moment I did this, you will be able to see that no intersection of edges takes place, and hence the graph is now a plane graph. Now I am in a position to write or find out the regions. So this one is one region, so R1. This whole is one region, R2, and then comes the unbounded region, R3. So how many regions are there in this graph? 3. So in this way, friends, we can find out the regions in a plane graph. Now let us come to dual graph. So what is dual graph? Dual graph is basically a graph which is generated from a plane graph, and the dual is basically a method of generating new graphs from existing graph. But the only constraint is that you should be starting with a plane graph. If you don't have a plane graph, then you will not be, and then you will not be able to draw any dual, because you will not be able to know the faces. Until unless you know the faces, then how can you draw the dual? So therefore, for dual, the primary constraint is that the graph should be a plane graph. Let's say I'm interested, we'll be taking three problems here. So let us start with this particular problem. Let's say I'm interested in drawing the dual of this graph. So what are the procedures? The first thing first is, what you have to do is, you have to mark down the regions. So you have already done it. So R1, R2, R4, R3, R5. So in total 5 regions are there. Then to draw the dual, what you have to do is you have to draw new vertices in these regions. So let's say this is one, this is another vertex, this is another vertex, this is vertex, and this is vertex. So the first thing is draw new vertices in the region. Okay, this we have done. Then what do I have to do? I have to find out the relation between regions. That means I have to find the edges which are shared by, which are in common between regions. For that matter, what I do is I write a table, I draw a table like this: R1, R2, R3, R4, and R5. And likewise, R1, R2, R3, R4, and R5. Now I look that R1 and R1, there is no sort of, there is no loop existing as such. So I will be writing 0 here. Now comes R1, R2. So this is R1, this is R2. They are sharing this particular edge, and hence this is 1. Why? Because only one edge is shared. What about R1, R3? This is R1, this is R3. They are not sharing any edge. So this will be 0. This is R1, this is R4. No edge is common. This. What about R5? So with R5, R1 is sharing two edges. One edge is this, another one is this. Okay. Once you do this, what you have to do, you have to find out the symmetric uh, points. That means if R1, R2 is 1, then R2, R1 will be 1. Likewise, R3, R1 is 0, and R1, R4 is 0. So R4, R1 will also be 0. And R1, R5 is 2, so it has to be 2. So basically this matrix is symmetric right now. Then comes R2. So R2, R1 is already there, then I have to go for R3 and R4 because this will be 0. Then R2, R3 is sharing this particular edge, so this is 1. R2, R4 is sharing this edge, so this will be 1. Then R2, R5, this is R2, this is R5, this is sharing this particular edge, so this will be 1. So likewise, this is R2, R3. So R3, R2 will also be, sorry, R3, R2 will also be what? It will also be 1. Then R2, R4 is 1. So R2, R4 is 1. So R4, R2 will also be 1. And R2, R5 is 1. So R5, R2 will also be 1. Now comes this R3, R3. No loop. So move to R4. So R3, R4. This is R3. This is R4. They are not at all connected. So no edge is common and hence 0. What about R3, R5? R3 and R5 are sharing two edges. One is this, another one is this. So what I have to do, in place of R4, R3 also I have to write 0. In place of this is R3, R5. So R5, R3 I have to write 2 because I have to make it symmetric. Diagonal symmetric up. Okay. Now comes R4. So this is R4, this is R5. It is sharing what? Two edges. So this will be 2. Now what about R4? R4 0. So this completes your table. Why? Because once you know what is R4, R4, what is R4, R5, so it is 2. So R5, R4 will also be 2. And hence this diagonal will be 0. Now the time is to draw the dual. So what we have to do? We have to mark. First, let us see that R1, R2 is 1. And here what I'll do is I will draw an edge joining these new vertices such that they are crossing that common edge. So this is the one. Then R1, R5 is 2. So R1 is this, R5 is unbounded region. So what I have to do? I have to cross these two edges. So one I have crossed like this, another one is this. So this is also over. So the moment this is over, automatically this and this is over. So this will also be over. Now we'll be coming to R2, R3, this one. So this is R2, this is R3. So we'll be connecting them. So this is done. So means R3, R2 is also done. Okay. Now comes R2, R4. So this is R2, this is R4. Join. This is over. This is also over. Now comes R2, R5. So this is R2, this is R5. Join it. So this is R2 and this is R5. So R5, R2 is also over. Now comes R3, R5. This is R3, this one, this is R5, unbounded. So two edges are there. One is this, another one is this. This is over. Now comes R4, R5. This is R4. R4 is this region. R5 is this unbounded. So two edges are there. One is this, another one is this. So friends, in this way, your dual is over. Now, the important thing here is, if you note this original diagram, this one, then what you can say, now very closely watch. In the original diagram, we are having 1, 2, 3, 4, 5, 6, 7. 7 edges. How many vertices? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, I am checking 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 edges are there. How many faces are there or regions? 1, 2, 3, 4, and unbounded 5. Now the similar thing what I have to do is I have to do for the dual. If G is my original graph, then the dual is represented as G star. So this information is basically for G, and similarly I have to do for G star also. So if you look, how many edges are there? In how many vertices are there in case of dual graph? That is n star. Also I have to find out the edges, also the faces. Now, if I evaluate the vertices in case of dual, then this is one vertex, second vertex, third vertex, fourth vertex, fifth vertex. Okay. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 edges. How many faces? This is one face, this one. This is another face, 2, 3, 4, 5, 6, and then unbounded 7. Friends, what you have observed? You should observe that the number of faces in dual is nothing but the number of vertices in the original graph. Likewise, the number of number of vertices in the dual is nothing but the number of faces in the graph. And as you have crossed exactly the same number of edges whatsoever are there in the original graph, that's why M and M star will always be the same. So the relation between this and this is N should be equal to F star, M should be equal to M star, and this F should be equal to N star. So this is what the relation is. You should remember it. Okay. Apart from this, if you look this particular graph, this graph I am giving you as a assignment, you please try it. Now we'll be focusing on this graph. So if we look this graph, then the question is, how many faces do I have? So in this graph, I am having R1, R2 and unbounded region R3. Okay, what is the next task? Draw these vertices. So I have drawn the vertices. Okay. How many vertices I have drawn? 3 vertices. Why? Because 3 faces or regions are there. Then what I'll do is, I'll draw that table. R1, R2, R3, R1, R2, R3. Now, right now, forget about the diagonal, only focus on off diagonal elements. So R1, R2, this is the common edge. So one will come here, one will also come here. Now R1, R3, R1 and this is R3. So two edges are common. So 2 will come here, R1, R3. So R3, R1 will also be 2. Okay. What about R2, R2? Forget about this is 0 for the time being, let's say. What about R2, R3? So this is R2, this is R3, 2, and this is R2 and this is R3. So in every case, whether it is R1, R3, so two edges are there. whether it is R2 R3, two edges are there. That means two edges are shared. Now if you look closely, this is what we call as a bridge. That means the edge which is connecting two separate graphs and making them as one. The moment we remove this bridge, the graph becomes disconnected. So whenever you have a pendant vertex, this, or whenever you have this edge lying like this, so for this pendant vertex, you, as this is in R3, so what should be there? There should be one edge extra to consider this edge or to cross this edge. And as this is in R3, so that has to start from this vertex, and this should come back to this vertex. So that means there is a loop. So whenever there is a pendant vertex, you will always be having a loop. So this R3 R3, you will be having a loop. Okay, so now let us draw it. So R1 R2, you have one vertex. Okay, I have drawn it. Then comes R1 R3. So this is R1, this is R3. First edge is this, second edge is this. No problem. So this is over, this is over. Now comes R2 R3. This is R2, this is R3. So two edges. So first edge is this. Sorry, I'm drawing it on the wrong place. I should not draw this. Oh, so this is R1 R2. So this is the one. Okay, now R1 R3 2. So this has to be connected here. Sorry. Now once this is over, now R2 R3, this is R2, this is R3. So first one will be coming from here and the second one will be coming from here. Now what about this one? This is forming a loop. Yes, you are right. So now this is forming a loop such that it is crossing this pendant vertex. So whenever you are having a pendant vertex, so pendant vertex will always result in a loop. Now if you start counting the number of edges, vertices and faces, then how many vertices are there in the original graph? 1, 2, 3, 4, 5. How many edges? So it is 1, 2, 3, 4, 5, 6. How many faces? 1, 2 and 3. Now in case of G star, that is G star, this is for G, how many vertices are there? 1, 2, 3. Very good. How many edges are there? 1, 2, 3, 4, 5, 6. And what about faces? So this has to be star because I am talking about dual. So 1, 2, 3, 4 and this unbounded 5. So again what we have observed is that n is same as f star, f is same as n star and m is same as m star. So the point or the catch in this graph is whenever you are having a pendant vertex, then that pendant vertex will give you one loop. Whereas if you have a graph in which you are having a loop and you want to draw its dual, then that loop will get converted into pendant vertex. Okay, so in this lecture, till this point only, in the next lecture, we'll be learning some more topic. Thank you very much for watching it.